everyone, and maybe morning, afternoon, midnight. In fact, good day wherever you're joining us from. And we have again another interesting session, one of the core knowledge sessions, that's what I call it. And today our special presenter is Aripriya. She's already here and ready for us. And I'm doing the intro now, so I'll be quick. And today's topic is maximize SQL Server performance with Read Committed Snapshot Isolation. We will try to have a dedicated Q&A at the end, so don't forget your questions, put them in the chat. I will thumbs them up so that you know that I've acknowledged them, and we'll pass your questions to Aripia at the end, and then we kind of wrap up at the end too. New interesting developments for our community is that we now have a website. We are now an official Fabric community. I will share all of these so that you can join them. And the Fabric community will expose you to additional benefits that come directly from Microsoft. So they do sometimes give exam vouchers, and Microsoft also is investing in the community. So I would say join this for sure. So that way, if there's any criteria of a gift going only to members that are on that platform, you qualify. So our presenter today is Aripriya Naidu. She's someone who is like, she's using SQL Server, like that's what she has done for a very long time and likes to share knowledge on. And we're very lucky to have her. She enjoys speaking at events. She speaks at past summits, SQL Saturdays, Boston, and even getting her to be on this session, I had to go into the core platform where we are able to attract, high-ranking speakers, and she's one of the people who we were able to shortlist. We got a lot, but our session is so unique that we decided that we have to also, get our session to happen soon. So we are already now having it. So we are fortunate to have her. I will maybe share her LinkedIn so you can follow her and be in loop of all her speaking engagements and the knowledge that she shares. But right now, I'm going to get out of her way so that she can present to us what she has planned for us. So, Aripia, thank you. I'm going to stop sharing my screen, and then you can take control of the sharing.
All right, thank you. And let me share my screen. All right, do you see my screen?
Yes, all is good. Yes.
All right. Okay. Hello, everyone. Thanks for joining. Today's topic is how to improve performance using RCSI, which is Read Committed Snapshot Isolation. And this is all about SQL Server, right? Let me just bring this up so I can go to the next slide. All right. So I'm a SQL Server database administrator, engineer, working on operations and engineering for close to 12 years now. And I started my speaking with New Stars of Data a couple of years ago. And since then I've been speaking at various events like SQL Saturdays and past summit events. And I found out that, all right, I think I like to speak. So that's what I'm doing. And I also write articles, especially technical articles on my blog. And that has also been about SQL Server and lately a bit about Postgres as well. So that's about me. And that's my, LinkedIn. If you have questions later on, you can feel free to DM. And this slide deck is on the GitHub link. On my GitHub link, you can find this deck, the scripts, everything. All right. So this session, why are we here talking about RCSI? So the thing is, what is the problem? The main problem here is we will be discussing about read versus write blocking. So throughout this session, you will hear me say multiple times read versus write blocking, because that is the gist of the session. So we are going to be working on resolving that read versus write blocking. And the agenda for today, I'll show you what the default isolation level of SQL Server is and what are its problems, and what is read committed snapshot isolation level, in SQL Server, how it works, what are the advantages of it. Also, what are the trade-offs once you enable RCSI. All right. So what is isolation? You want to have transactions running on your system, not interfering with each other. So that is why you have isolation. Like, if two people are editing the same document, you don't want those two people or the two writes to be interfering with each other. So that's why we have isolation, and we have many levels in isolation based on the locking model. So based on the locking model, you have 4 isolation levels, which are read uncommitted, read committed, repeatable read, and serializable. But based on the locking and the row versioning model, which I will explain in a few minutes, we have 2 models, that is read committed snapshot and snapshot. In this session, we will see a lot about what read committed snapshot isolation level is. But before that, we have to understand what the default isolation level in SQL Server is, which is read committed. So what it will do is, this will read only committed data on your table. If you're writing something, it will not read any uncommitted data, or it will not write on any uncommitted data. It can only read your committed data, and it can only write on top of committed data. And that's why this isolation level is called read committed. When you look at it, it is very simple. All right, so it reads committed data, it writes on top of committed data, right? But the way it is designed, there are a few issues with it, or maybe you should not call it issues, but this is how the design is, where we have a few problems. When you run an update statement on a table, it needs an exclusive lock. And simultaneously, on the other window, if you run the select statement on the same table, now this select will need a shared lock. Now what happens? You're having a blocking problem, right? So when you check with SVO is active or any of your favorite queries, what you will see is that update is blocking the select query. So this is called read versus write blocking. So at any point of time, you cannot have both update and read running at the same time. It will be blocked, whichever query comes next. Usually it's the select query coming in, trying to read, it's blocked because update has that exclusive block. So that's what you will see with this read committed isolation level. So how can we resolve this? Well, there are a few ways you can do. One, you have to always keep your transactions short. Not only for the blocking, it will help in many different ways that you can imagine. Always keep your transactions short, and optimize your queries, like how well you can optimize it nowadays, with AI and everything. I'm not even going to get into it, but so you can do that. You can add enough indexes, things like that. But even after you do all of this, you will still have blocking because that's how the engine is designed. So what you can do now is enable this isolation level, read committed snapshot isolation level. All right. So until now, what we saw was what is the default isolation level in SQL Server, which is read committed. And in read committed, it can read only committed data and write only on top of committed data. You cannot have both write and read queries running at the same time. They will get blocked. And that's why we are moving now into RCSI, which is read committed snapshot isolation level. So how do you enable RCSI? If you see the picture here, you will see that is read committed snapshot on equals true. You have to set it true. And after you set that to true, you can verify if that's enabled using this query, which I will also show you in the demo. And also you need exclusive access when you set the database to RCSI, usually in the maintenance windows or over the weekends when things are very slow. And there are multiple ways you can check how RCSI is enabled. All right, so let's take a look. So the first thing, on the left side, we have a table called T1 with 2 columns. And on the right side, we have TempDB database. So when you want to run the update statement, what happens is, first step, when you're on RCSI, it will always make a copy of the committed data into the version store. So now this row will get copied into the version store. And Now it will run the update statement. If you see in the default isolation level, it will not make a copy to the version store. It will just run the update. But in this RCSI, step 1 is to copy that row into the version store. That is the key point here. All right. So copy the data and then now run the update statement. So now when the write operation comes in, it will be reading from this table, and the read operation comes in, it will be reading from this version store, which I will show here. You see this, when you have that write, it will just directly read from the table. And when you have the select statement coming in, the select won't be reading from the table now because you have a copy, the latest committed copy onto the version store. So the select statement will go to the version store. So what are you achieving? No blocking between read and write operations. So this is what we get out of RCSI. And this is the main reason you enable RCSI, that way read operations are not being blocked by write. And let's run through a few scenarios. So imagine you have a write operation coming in to the orders table, for example. Now it takes an exclusive block. It will make a copy of the previously committed data into the version store. All right. Now when the select or the read operation comes in, it will read from version store. So this is the basic understanding of RCSI. All right. Now let's go to the second scenario. This is RCSI enabled database, and you don't have any concurrent operations at this point of time. All you have is a select statement. Does it read from the table or does it read from the version store in TempDB? It just reads from the table because there are no concurrent write operations going on. It does not have to go to version store at all. It will just read from the table. All right. Now we have another scenario. Imagine if read comes first, that read is just reading from the table. Now, if the write comes in after the select operation or when the select operation is in process, now the write comes in, what happens? Will it get blocked? Because in your default isolation level, this will get blocked. But what happens here is the main difference. You see this? When the update comes in, for those rows, a copy will be made to the version store. Now the select will immediately go to the version store to read those rows without getting blocked. All right. So that is the, like the key difference between default isolation level and this read committed snapshot isolation level. So you will have no read versus write blocking. And in this picture, let me show you, you have a new table. All right, let me zoom in here. You have this new table here created. And if you check the DBCC page on RCSI enabled database, you will see this versioning info here. And you will see this, version pointer null, because we have not done any updates or deletes now. It's only an insert. Insert does not need to have any versions because insert is a new row. There's no previous version of it, right? So this is how it looks like. Now, if I run the update, what happens is, you see this here, you will have version location in TempDB. That's what it says. So the reason I'm showing you this DBCC page, I know these are internals, but the reason I'm showing you is so there is a better understanding of how the update statement runs and what happens in the page level. So it will tell you TempDB version location. It will show you where the previous committed copy of this row is. All right. So if you see here, it will say version pointer null before any update runs, but after the update runs, it will show you where exactly the location is. So this is how an RCSI enabled database or tables look like. So out of all of this, all you have to understand is write operations will always go to the user database and read operations will go to the version store in TempDB. That way there is no read versus write blocking. And that's the main purpose of this RCSI database. All right. Any questions? I mean, you can feel free to post anything in the chat. If you have any questions, go ahead and post them. And do you have anything right now?
I'm checking. The only question is really not to use. It's the Slack I posted is wrong, but I can see Manish is typing. So maybe there will be a question for you.
Okay. Probably I can give a film.
Okay, I can keep monitoring. So maybe.
Okay, yeah.
Oh, okay. Yeah, I've seen it's done typing.
Okay, Manish has a question. Until how long this version store will be maintained? So as soon as the write operation finishes, and after that, version store cleanup takes place, usually in a minute. After the version store cleanup takes place, then that row in the version store will be cleaned up. So that version will remain in the TempDB until that write operation is finished and the cleanup has to take place, which is usually in less than a minute. Cleanup takes place like every minute or so in the background. All right, let's keep moving, and feel free to post any questions that you may have, and I will pass in between to answer any of them. All right, back to the slide. So when should you use RCSI? Like I said, the main thing is read versus write blocking. Usually, where will you see this? On OLTP servers, mission critical OLTP servers, where there is very highly concurrent transactions going on, and you have a lot of write and read queries simultaneously going, then you will see a lot of blocking and things like that. And in Postgres, if you see, this is also called multi-version concurrency control, where there it is default, but here this is not the default version. You have to enable it. And on Azure SQL, this is the default isolation level. So what I think is, because in Azure SQL, usually they test things out. So, I don't know if this will be made default on SQL Server, but for now, this is not the default. And, there are so many trade-offs as well if this is the default isolation level. So anyways, for now, RCSI is not a default. And if you want it, you have to enable it based on your environment and needs. If read versus write blocking is not something you see on a daily basis, or is not something that's impacting, your production, if you don't have to worry about it, then I think you don't have to do it. Right? Only if this is a problem, then you go ahead and enable it. Just because there is a feature or just because something is working fine, that does not mean you have to do it. But if you see this as an issue in your server, then I think you should go ahead and enable it. But at the same time, you should also understand the trade-offs that come with it, which we will discuss in a few minutes. All right, so just summarizing what we discussed, in read committed, if you see, you have blocking almost, with everything except for read versus read blocks write blocks write, everything. All right. And in read committed snapshot, of course, you still have write versus write blocking. That will not change. That will surely be there. That's how the design is. The advantages of this RCSI is read and writes, they can run concurrently. That's a big plus here. Right. So what is snapshot isolation? Now that we discussed about RCSI, the snapshot isolation is also something that comes up. So I just want to quickly show you what that means. What you do here is, all you enable is just that allow snapshot isolation to true. And what you can do is, if you want your statement to read from the version store, then you set that statement on the top, set transaction isolation level snapshot. Then you are telling the engine that, hey, for this select statement, read from the version store. When you're in this isolation level, if you don't mention set transaction isolation level snapshot, then it will not read from version store. So that is the main difference. With RCSI, you don't have to mention any isolation level statement in your query window. But with this SI, you do have to mention if you want to read from the version store. So that's the difference. The code level change is there for SI isolation level. I thought I'll just show you quickly. That way, what's going on between RCSI and SI. Well, in simple words, read committed means you're reading committed data from the table. Read committed snapshot means you're reading the committed data from the snapshot, where snapshot is nothing but the version store. And snapshot isolation means you're reading the committed data from the snapshot only when you explicitly set the isolation level. All right, so that's the difference between each of these isolation levels. So when you look at it from a distance, you'll be like, oh, isolation level is that a complex topic? What do I do? How are the internals? So many things, because I had all those questions as well. And I was like, oh, I don't want to go into this. And then it was, I think, a few years ago when I actually worked on this RCSI, and that's when I realized, oh, this is not as complicated as I thought. Because you'll be wondering, this RCSI isolation level came out in 2005, and I didn't even realize we could set this up to avoid this read versus write blocking, probably I think in 2019 or 2020. That's when I was like running into some issues, and I found out, oh, so read versus write blocking can be avoided if you do RCSI. And that's when I dived into it and found out so many things going on, version store, TempDB, and everything. So this is something, even though this was released 20 years ago, it's not that everyone is aware of it. So, if this is something you have an issue, then you can go ahead and do it. But before you do it, like I said, understand the trade-offs and also the differences between each of the isolation levels. That way, you know what is suitable for your environment. All right. Version store. The moment you have version store, you have to monitor it because there are so many things going on. But from my experience with the production servers and with the version store, the moment you have an issue with version store on TempDB, I'll tell you, like, this is the golden key point that has worked for me is check for uncommitted transactions or open transactions that are there for a long time, because that's the one that is filling up your version store in TempDB and causing an issue. All right. So the moment something is in TempDB, you're going to check for any open transaction or uncommitted transaction. Not only for RCSI, anything that you work on your SQL server and you have an issue in version store, you get alerts. The first thing you check is these uncommitted transactions, because they will not let the cleanup take place and your TempDB will get filled. All right. So I'm going to give you an example how this version store works and why it creates an issue for you. The reason I came up with this, analog is to make sure the understanding, how it goes across is easier for you to understand this. All right. So let's take a single lane road. Consider it one way. You have many cars there, and there's a red light. And if you notice, there is a red car, and the driver is sleeping. I'm calling the driver sleeping. It's because I want to relate this to a sleeping transaction. All right. Now there is a green light and the cars in front of the red car left. But the cars behind the red car, they cannot move because you have that red car driver sleeping in front of you, right? So let's apply this same logic now, because this is how version store works. Any transactions that come in will get cleaned up. But the moment you have a sleeping transaction or an uncommitted open transaction, then any of the transactions that are behind it will not get cleaned up, regardless of the databases they are coming from, because TempDB is common for the whole instance, right? So the moment you have an uncommitted transaction, the cleanup will not take place, because just like how you see these cars, anything that's behind it cannot get cleaned up. And let me show you this one now. So I'm just giving you a table. This is not from any DMV or something. I just came up with this. That way it's, again, easier to understand. So if you see, first is the time column, and then you have the transaction ID. That's not how a real transaction ID looks, all right? Just only for simpler understanding, I put it that way. and you have the status there, and space consumed for each transaction, and which database they are coming from. So if you see, for every minute, you have a transaction coming in, a couple gigs it's consuming, and they're all from different databases, all right? Now, this is all in version store. Now the cleanup takes place, right? What happens? The cleanup task runs in the background, all right? So when the cleanup takes place, the first 3 transactions are committed, so they can get easily cleaned up, and this 2 gig plus 3 plus 2, 7 gig, they can get freed up. All right, you will get that 7 gig back. Now again, the cleanup runs. It cannot do anything here because that is a sleeping transaction. It is not committed. All right. Again, the cleanup task runs. It cannot clean up anything behind transaction 4 or anything that comes after transaction 4. It cannot clean up anything, regardless of the database it comes from. That's because whatever is in the first, that has to get cleaned up. Only then the remaining ones can get cleaned up. This is a major point in understanding how the version store in TempDB works, because this will unlock so many other topics, not only RCSI, this will help you unlock so many other things in SQL Server that's going on, all right? So version store in TempDB can get cleaned up only if you have all committed transactions. So that's something, because I have learned it the hard way, and that's why I'm, emphasizing this so many times. So what happens now? The remaining 25 gig will not get cleaned up. Imagine this is on a production server. Transactions are constantly coming in and none of them can get cleaned up. Now this will become from 25 to 50 to 100 gig, whatever your max memory is. Everything is going to get, not the memory, sorry, the space, whatever the max space you have for your TempDB, everything is going to get filled up. And what happens? Your server, you cannot access your server, right? So that's something important you understand. Please post if you have any questions. All right. This is exactly how I felt the first time when I turned on RCSI and didn't understand how the version store works or how the cleanup takes place. I thought I was fixing something and instead ended up crashing the server. So I hope now you understand why I kept emphasizing about the version store cleanup and everything. I tested things on, lower environment, dev test and everything. You don't have that many transactions coming in. So it did not blow up my TempDB on lower environment. But when I did it on production server, yes, I was so happy I fixed something. I felt so proud about myself because I was fixing the read versus write blocking on a production server. I got it all done. And then I did not monitor TempDB version store because at that time I didn't know how the cleanup takes place. And of course, to my surprise, I saw after I think probably a few days or so, there was an uncommitted transaction or some open transaction lingering out there for hours, and it filled up TempDB. And I was like, why did this happen now? It never happened before. And that's when I dug into a lot of things and found out, oh my goodness, okay. So RCSI is using version store, and this is not even from this database. So why is it coming from the other database? I had so many questions. Like I said, version store in TempDB is common for all databases. So it really doesn't matter, like if you're using DB1 and something on DB2 is blocking it, that's how TempDB is designed. If you have, uncommitted transaction from any database, it's still going to not let the cleanup happen. So, don't be like me, feeling proud about fixing one thing and then blowing up the whole server. So the thing is, when you enable something, that's why I keep saying, please do understand the trade-offs that come with it. And, there's going to be trade-off with anything that you enable or that you work on. So you just have to find out, what's best for your environment. So you know the pattern of your server and you do the best, right? Okay, and the important part is monitoring and troubleshooting. Like I said, if you don't watch out for version store or MDB alerts, then you're going to blow up the server. So there are some DMVs that you could use to monitor the space usage and everything. And I do have the monitoring scripts on my GitHub. You can You can get those scripts and see how it works. But of course, don't go and do it on production right away. Do it on dev or test environment. See how it works for your environment. That is very important. And then you can do it on production. All right. So RCSI, if you ask me, that is actually a good one to do. If you have read versus write blocking, it does help you. But remember that it comes with a trade-off where you have to monitor your TempDB usage and you have to monitor the cleanup as well. Right? Any questions?
Yes, we already have about 2 questions, and just to let you know, we all love your illustrations and how you are making this like impossible to not get.
Oh, thank you. Okay, that means a lot because that's my whole point. Make it simpler for people to understand. Yeah, thank you.
I was like thinking this is going to be a very complex topic, and yes, it's a big concept, but you made it like very easy to understand. So I'll start with Avish's question. Let me read this question. So while you are mentioning about I forgot exactly where you are. So he asked, does this help with application that runs queries with implicit transaction on?
Yeah. The moment you're using TempDB with temp tables or variables or whatever uses TempDB or even regular queries, right? That does hash tables or sorting, whatever is using TempDB, and you're doing update delete statements. It is still going to use version store. Yeah. The moment you have RCSI, it is just using version store.
Great. Then Avish actually has a second question. So this was when you were talking about how that
if there are other
uncommitted
DBs
transaction.
with okay,
Yeah.
so this will sorry, I just read it so I get it. This will only happen if there are other DBs with RCSI as well, right? And not once. Yeah, that is correct. So, when it comes to version store, if you have multiple databases with RCSI, then yes, it's only for RCSI, which will use version store, not for the read committed. That's correct.
Thanks. And that's all
good?
the questions for now. Yes,
okay.
we're good.
Let's go ahead. Okay, NOLOCK. I know everyone loves it. So the reason I'm bringing this NOLOCK up with RCSI, it's because if you are in your default isolation level, then yes, you don't want to cause blocking. So, you're using NOLOCK. That way you're not causing any blocking on the system. But if you have RCSI, you don't have to use this hint. All right, because with RCSI, what happens is when you when you run the select statement, it's going to read from your TempDB version store and it will not cause any blocking. So with RCSI, you don't have to use NOLOCK. So that's one thing. And please remember with NOLOCK hint, though it appears faster to you, it's going to do some dirty reads. Dirty reads in a sense, it's going to read uncommitted data. So your results might change in the next few seconds when you run this again, your results might change. All right, so that's one thing you have to understand. And another important point is when you have NOLOCK, then it means you are having uncommitted isolation level, read uncommitted isolation level. So whatever isolation level you have, all of that will get overwritten. The moment you have NOLOCK hint, your isolation level automatically changes behind the scenes to read uncommitted. All right, so when you have to use NOLOCK is, when you're doing something with, for example, you're just staging data from one table into another table, and you want to check the progress of how the load is going, then you can use NOLOCK because you don't need accurate data. You're just checking, okay, so it's progressing, the count is progressing, you're good. So those cases you can use NOLOCK when accuracy is not needed, but you should not be using NOLOCK. But fortunately, or I should call unfortunately, there are so many places in the application where NOLOCK is being used, even on very mission critical OLTP applications or when accuracy is needed. Please do not use NOLOCK, and that's why we have RCSI. So when you have RCSI, you don't need to use NOLOCK because you're not going to cause blocking with your select statement. And the select statement is going to give you only the correct data, which is the committed one. All right, so that's the main difference. I want to bring it up. When you have RCSI, please remove NOLOCK from your code. If you have NOLOCK, it's going to make it read uncommitted isolation level. As simple as that. All right. I know developers love NOLOCK, and I'm not going to get into that argument because it's a big deal changing the code and everything, and I totally get it. But when you're using it or when you have it in your query, you have to also understand how the isolation level plays behind the scenes. All right. You think it's making it faster? Well, yes, a few microseconds or something, it's going to make faster, but is it giving you the accurate results? No, it will not. All right, so that's something you have to understand when you use NOLOCK as a hint. All right, I'm going to head into the demo. Michael, do you think we have enough time, or we'll just summarize and do the takeaways?
We have enough time.
Okay, that's good. All right. Let me bring up my SSMS. So what happened? I'm just going to minimize my screen on the other monitor. Sorry if you're just like staring at this because I can't see what's going on. All right. Okay, so this is my, I'm just using SQL 22 instance. I'm going to check the isolation level. Well, there are a few ways you can check your isolation level, but I'm going to be using this. And if you see the last column, this is the isolation level. You see read committed, all right? So that's the default isolation level. The moment you install SQL Server, that's what you're getting. So what I'm going to do now is run a select statement T1, which I already have. I have 10 records in there. Okay, so the next thing I'm going to do is run an update statement, like an explicit transaction. I'm doing it explicit, that way I can show you the blocking between the screens. All right. So now let me go ahead and run the select statement on the other screen. I want to bring this folder on the other side so I don't distract you. So I have this update statement not committed yet. And on the same table on the other window, I'm going to run the select. And of course, this will not finish because this needs a shared lock, but this update is holding the exclusive lock. So on the other window, this will still be waiting because it is blocked. Let's see what the block is. I'm using this XP who is active. And if you see here, the first one, we ran the update statement, right? So that's actually blocking this select statement, which we ran in the second window. You see, it's waiting for the shared lock. All right. This is how the default isolation level works. When the update statement is in process, your select cannot run on the same table. It will be blocked. And this is the blocking that we are trying to resolve with read committed snapshot isolation level. All right. So whatever you understood or probably did not understand in this whole session, at least I want you to walk away with the time you spent here with just one thing. Read versus write blocking can be resolved by read committed snapshot isolation level. So that's the main takeaway here. All right. Okay, back to the demo. So we have this update that's blocking the select statement. All right. So what we're going to do now is let me go ahead and commit this. And before I commit this, I'll still show you. You see how this is blocked. So let me go ahead and commit this. The moment I commit this, now the select statement will give you the rows. Now see this in the second window, the select just gave me the rows here. All right, so this is how it works. Until you commit, your select will be blocked. So what are we going to do now? You know that read is blocked by write. And in this case, that's why if you see in many of your queries, you will have no lock because that way you can read the data without being blocked. But our intention is we don't want to use NOLOCK because when you use NOLOCK, that means you have the possibility of reading uncommitted data, which is not accurate. All right. So this is the default isolation level. What I want to show you now is how does it look when you have RCSI. And before I enable, let me show you the isolation level right now. So isolation level right now is 0. Read committed snapshot is 0. That means it's not enabled yet. Now let me, okay, so before you enable RCSI on a database, make sure you don't have any active transactions, or it's because you should not be having any active transactions when you enable RCSI. So do it in the evenings or weekends or maintenance window when there's very less traffic. All right. So this is the one I'm going to be using, Alter Database Set Read Committed Snapshot. This will enable RCSI on your database. This usually takes a few seconds, even though there are no active transactions. It usually does a bunch of stuff in the background, and you will have RCSI enabled. So once this is okay, you see this? Now this is enabled. That's good. And now if you check the level now, you see earlier it was 0. Now the read committed snapshot is enabled. So that's good. You can also use this way to check as well. You will see here, the last one, you see this, read committed snapshot. All right. Now what I'm going to do is run the update statement on a table. I have not committed it. See it, just begin tran, and I left it open. Now on the other window, I'm going to run the select statement. Now this select statement should not get blocked because we have RCSI enabled, and that means this will read from version store in TempDB. Got it? So in this window, if you see, this update is still in process. I have not committed this. But if I run the select statement on the other window, this is not getting blocked because RCSI is enabled. And also, if you notice the result here, you see how this is default isolation, which is nothing but the previously committed data, like whatever is in the table. This does not have RCSI now. You see B is RCSI now, but your select statement will not show this uncommitted data. It will only show you the previously committed data. All right. And if you also check the logs at the same time, there shouldn't be anything. It just shows you that open transaction. All right. There is no blocking because your select is not going to the table at all. It's not requesting a shared log. Your select is just going to the TempDB in version store. All right, so that's the difference between default isolation level and this RCSI. There will not be any read versus write blocking because read reads from the version store in TempDB. We can take a look at the version store. So if you see now, you will still have 1 because that row, did I commit it? Let me go back and look. All right, or probably I could just leave it. Let me see, it will show you here. Okay, so if you check this at DMV, you will see 1 row because that 1 row we tried to commit. And you can check the space consumed in TempDB by using this DMV here. And if you see this, it'll show you the database name where we tried to run and the amount of space it's consuming. And you can also use this active snapshot transaction DMV. It will show you what transactions are running on which database for how long. All right, so this is the query that I actually use on production server very often to find out what queries are using the version store actively. All right, and which databases it's coming from, what is it using, how long it's running. Sometimes you want to kill some sleeping transaction, then you can do it from here. All right. All right, so these are the demos I wanted to show. Of course, I do have more, but I see it's 8:46 already. So I'm going to pause it here and go back to my thing. We're almost done. Any questions with the demo?
Checking. No questions, but I see Dipti is asking if there's a YouTube where we post all the. I'm going to do that and share. We have, so hopefully in today's session too will be there. But that's the only question that I see. I'll answer the others. All right. All right, so we saw the demo, and this is the last slide for today. So the takeaways here are: to resolve read versus write blocking, you can use RCSI. And one more thing is, for write operations, there will still be locking because that's how the design is. Write versus write blocking will still be there. All right, we are not resolving write versus write here. It's just read versus
right? And you have to watch the space usage for version store, because the size will increase as the transactions come in, and you have to monitor the any sleeping transaction or uncommitted transaction. That's very, very important whenever you're using RCSI or version store in TempDB. Again, NOLOCK, if you don't want accurate data, then you can use NOLOCK. When you have RCSI enabled, you don't need NOLOCK at all. All right, so that brings to the end of this session. And like I said, if you have any more questions, after this session, later on tomorrow or something, feel free to DM me on LinkedIn, and I'll be more than happy to answer your questions. And you can get this slide deck and demo scripts. I do have, a bunch of demo scripts. You can get them on GitHub, right?
Thank you. And we have one question just about when I was telling you there was no more questions. So let me scroll to where the question.
So if we roll back transaction, then version store will be also rolled back. Is that correct? Yes. If you're rolling back your transaction, yes, then those transactions will roll back and the cleanup will take place. Yes.
Okay, and
as long as the transaction is just left open, you should be good. Yeah, that's the only thing. You cannot just leave it open or lingering over there, then that's an issue. But if you're either committing or rolling it back, perfectly fine.
okay. I'm also grabbing the GitHub link. So I'm trying to grab the GitHub repo and share so that it's easy for people to just also get the resource that you've provided. Okay, if you have more questions, please ask. But in the interim, I'm going to throw the house questions to Aripia. I didn't give a heads up, but they're easy questions. So two. One is about, your journey, how you ended up in doing what you do, as far back as you want to go. We'll appreciate. Have you always known from, I don't know, from when you are 3-year-old, 4-year-old, that this is what you will do? Some children already know what they will do at that age, but just tell us how your journey has been, the turns and twists.
Sure, yeah. So, I can talk as long as you want, but I just don't want to get people to be bored. But of course, I'm happy to share. So I was born and brought up in India, and I've moved to the States after my bachelor's. So I think that was 15 years ago. Well, I'm giving away my age, but yes, I know you're all calculating it, but that's fine. So yes, I did my bachelor's and then I moved to the States, did my master's here, and then got a job. I didn't know anything about SQL Server at that time in my first job. I was just looking at the keyboard, looking at SSMS, like, what the heck is this? I don't know. So, and then they were all talking about so many things. The team was discussing. I was just clueless. I'm like, am I even in the right job? So, it was like that in the first few months. Yeah, I did learn about SQL Server. I did like it. So the first 3 months were kind of hard, but I did probably did some homework, I guess. So after 3 months, that was a contract role. So after 3 months, I got offered a full-time role for that position. I was like, oh, okay. That was cool. That was like an encouragement, especially at that point when everything was new. So that's how it started. And then I started, of course, learning a lot about SQL Server. Then I had kids, and then it was all about SQL Server, I guess. I didn't actually learn about any of the technology until recently. SQL Server by itself was vast, and it is still huge, lot of things. So yeah, I was just into, I think the main thing I will tell is, don't just do the things that you do at work. Well, still do the things, that's important, right? But there are also many things that you have to learn out of the job as well. I'm not saying that's easy. That's difficult with the family, kids, or whatever responsibilities you have. You have so many things going on. It's not easy. And it's also not easy to be motivated all the time. So that's also one thing. But anyways, going back to my journey. So yeah, I did that and then moved a couple of jobs. And yeah, I had a lot of got a lot of opportunity to work on production issues. That's how you end up learning. And I was on call and things like that. And then, yes, that's how it started. And especially with my speaking journey, I I started speaking in 2024, exactly 2 years ago. Yes, exactly 2 years ago. I was actually, I was feeling like I have to do something and I don't know what to do. I wanted to do something, and that was there inside. I was like, I have to do something, but I don't know what. And I started attending the user group in Boston. um, yeah, I started attending the user group. It was very good. I like the user group here in Boston. And I talked to people, and then I met a few people, and I happened to meet my mentor, Deborah Melkin. And I asked her, hey, can you help me speak? And she mentored me through speaking and everything. So that's the first time I spoke at New Stars of Data. And I was like, oh, I think I like this. So I liked speaking, especially the point here being is, sharing what I learned, and especially the mistakes, because it's very hard for people to learn and then, do stuff and everything. So I was happy in sharing my mistakes so it will be easy for others to learn as well. So that's how it started. And then I started getting many more opportunities after that. And then I started writing as well, technical blogs. That was interesting. And I think, oh yeah, I have to mention this. And I think it also felt very good when Brent Oza recognized my technical articles. I think he posted my blogs in his newsletter, like at least I think 5 to 6 times. I was like,
Wow.
oh my God, what's going on? So it was like that. And yeah, he gave his post, and then he also posted me as a role model in
Mm.
one of his presentations. I was like, oh my God, is he all right? I don't know what's he doing. So that's what I was thinking. But yeah, it was all good. All that encouragement and support from the community, and so many people. Of course, Deepthi, she's one of my good friends. We both always have a fun time. We have only met a few times, but every time it has been like, it has been really, really good. So even at the MVP summit, it was so nice. Deepthi and I, we both were there. We spent a good amount of time. So yeah, so it was all good. So I think this is my journey. It has been good, but I don't know. I think we have to just keep learning. And I know it's easy to say, but it's not easy to do. Even I don't feel
Yeah.
motivated all the time, but we have to remain consistent, which is not easy. So, but otherwise, I
Yeah.
think things have been good.
I
Yeah.
think
So this is my, all right. Yeah, you go
uh,
ahead.
I think you've also made your answer as easy for us to understand as the presentation. So I'm going to throw in a twist because I can tell you it's not easy in your space to be focused and know something as deeply as you know when there is always a new thing that is like this is what everybody should use. There was the at first end of on-prem and cloud,
Yeah.
and then at a point it became even the cloud. People wanted it such that you don't have to have people manage and you just have people just run queries and you let the cloud platform handle all of the deep things that you already are aware of. And then there was all the talk about data bricks and snowflakes, and there's always things happening that how did you stay the course and how are you able to even identify what is worth spending time on? And because even if you can learn everything, you cannot do everything, right? So you have to choose what you want to like focus on. How have you been able to manage all of those in quote distractions and staying focused to where you think you want to play in?
Yeah.
I want you to tell us how how you've been able to stay focused. How do you decide what is worth spending your time on and learning, and how do you truly know when something
Oh,
is an
okay.
existential
Are you
risk that will
asking
probably
me?
yeah
Yeah. So
because
what I usually do is at least what I have done is I don't try to, get into many technologies at the same time. I don't think it's going to do any good. I understand, there's always fear of missing out. There are so many things coming out. But what I think my understanding has always been pick a topic or pick one thing and go in depth instead of just learning the basics of everything. I would like to master one thing, like, for example, SQL Server. You cannot master SQL Server as a whole. At least I don't believe that. It's not easy. There are so many topics in SQL Server that, for one person to master it, it's not easy. Forget about other technologies. For every technology, it's the same thing. So pick the most important topics, like, some 6 to 7 topics that will help you, in the jobs or whatever it is. So pick a few topics in SQL Server and you have to master in them, which will take, if you are consistent, it will take a couple of years. So you have to master in one technology first, like you can be a lead or you are the subject matter expert. You have to be like that. Then now you choose get into another technology. So once you understand how the database engine in SQL Server works, not just the surface of it, like understand what goes in, what comes out, like what's going on, why, and so many other things. Then now you can go to Postgres, or I know Postgres, many people are talking about it, and I'm learning that as well, because in the earlier years I didn't want to like wet my feet in many things. Then I wanted to be a subject matter expert in one thing first. So depth is more important to me than breadth. So I wanted to do, and that's why I'm doing SQL Server, because my job is SQL Server. So this, and now that I've gained some good amount of understanding, I know how the engine works. I'm not saying I know exactly everything, but at least I can I know how the internals are, how the engine of SQL Server works. So now I'm learning Postgres, which means I can compare both the database engines and see how this one does, and I will know the pros and cons and things like that. Yeah, like you said, just because now Snowflake is there or Databricks or this and that, no. Maybe you can try to see, oh, what this is, what that is, like for a few minutes, but keep a set number of weeks for one technology, master that, because it's not going to do any good if you're just learning the basics of all the technologies. I don't know what good it's going to do. At least I'm not very interested in that. You have to master each one. So when after a couple of years, if you turn back and see, if you give 6 months to one technology, then at least you can master 3 to 4 good technologies in a few years, which is good, instead of jumping here and there. I know, because that's how LinkedIn shows us, or that's how AI tells, or that's how people are. Oh, learn all technologies. Oh, blah, blah, blah. Yeah, depth is more important. You have to master one thing first and then go to the other thing. That's how I've always been. I don't have this fear of, how is it going to be if I don't do this, if I don't do that, because there is pressure. You will be misguided. Because there are so many things coming out every day. No, don't worry about it. Or if you want to learn about AI, it's good. Learn that, see what the basics are, see how things work. Fine, that's it. Go focus on your SQL Server or whatever technology you're working in. Just learning AI is not going to fetch any job, but use AI as an embracing one. I love AI. I use AI every day, but it's like you have to embrace AI like it's like a tool sitting right in your computer that's there to help you out. That's how I see it. So everything is like that. I think I'm sorry for the long answer, but
No, it's that's what I was hoping to get, like
yeah, I mean,
the answer
even
that
in
is the strong
AI,
answer, the truth we need to hear, right?
sure, yeah.
Yeah.
Even in AI, you see how everyday posts are, news are. It's about, one day they talk about Claude, the other day it's about the other thing, then the codex, then this, then that. Every model or everything is going to get its own rave reviews. One thing is going to do better than the other. Just pick one thing, what is suitable for you. For example, I like Claude, and that suits my thinking. So I go with Claude. Some people go with Gemini. So it's not that you have to use everything, or if you're using one thing, you're not missing out another thing. That's fine. Just go into one thing, use one thing, and what I tell you is try to see what are there outside, but master yourself into one thing first. That is what will take you places than anything else.
Thank you. So I'll end with one more controversial question.
I'm
So,
happy to
what's
share.
your take on certifications? Do you think there's value if I'm not going to be a trainer, do you think there's value in people, putting so much effort in certifications?
Yeah, I'll be honest with you. I've done a couple of certifications, and I don't see any value in certification other than knowing, oh, what all are there in that, AWS. Oh, I have these many services, fine. But just with certification is not going to take you anywhere. I would rather spend all that time in learning topics by doing demos myself. That is more helpful. That will take you a long way than just doing the certification, just memorizing stuff and getting the certification. I'm not a big fan of certifications, though I did it myself a couple of times due to other factors. But if you have a choice that if you don't have to do, and if you're not asked to do, then don't worry about it. Just spend that time reading and doing demos yourself is what I would tell.
Yeah, thank you very much.
Yeah, sure.
Sorry for putting you on the spot, but
No, no worries. I'm
that's
happy.
what
I'll
we
at
want to
least I'm
hear.
happy to share my experience. That way people
Thanks.
who are probably in their earlier years of their career, if that helps them, I'm more than happy.
Thank you. So, to everybody who has stayed to the end, thank you. I have shared Aripria's links. Let's see if I can just copy paste them again so you can connect with her on LinkedIn. You can also subscribe to our Substack. I'm not surprised that Brentosa referred to your post. I looked at them. They are deep. They are full. It's not like you are sharing. It's almost like your session today. You started with the concept, the things we must know, and then you do the demo. And I look at your post. It's the same thing too. You will start with explaining the concept, then you do even in a blog post. You will do screenshots of code of those concepts at work. So, I'm not
Thank you. I mean,
surprised
thanks
at
for the
all.
kind words.
Yes, so I'm sharing again all of those before I end the session. So now I've posted your Substack, and I think I'm supposed to share a feedback link. Let me just quickly do that before I forget. So this is for every attendee to let us know what aspects of our session is already good as is, maybe the platform, maybe the hours, whatever it is you want us to know, and how much you like today's session. So that's the end. I hope I didn't miss anything. Let me just check my notes. I think we are good. Yes, I've shared everything I'm supposed to. And I would say a very big thank you to everyone. I'm surprised that a lot of people stayed till now. Thank you. I suspect that you're also finding even the questions that Arepia is answering regarding our take on the space and our own journey. Found it valuable. I have found it valuable. It's helping me to be staying focused because I'm easy to be distracted because we all scroll on LinkedIn and sometimes it makes it look like we might become left behind. And the truth is what she has said. No one, I've never seen any company hiring and they want you to know they will value you because you've touched a lot of many things and you're not deep in one core technology. So I'm glad that someone is telling me that truth so that I can recalibrate. So thank you, Aripia. Thank you to everyone. And we'll put the recording on YouTube this week. And I hope to see you again in our next session. I'll just share the link to where you see all our events so you know the session is coming up next. And that way you can, let me just do that now, and then we can I can close the session. So let me.
Yeah, thank you so much for the opportunity, and yeah, thanks everyone for joining the session. I know it's late, but yes, thank you again.
Yes. So thank you very much. I've pasted all I need to post now. So thank you, Aripriya, and thank you to everyone. Bye.
All
See
right,
you
bye.
next time. Okay, ending.